So we'll continue with the next part. New metric part. First we'll do the mount plate, that is here. Go to your top view first. The biggest diameter is 81. So we'll draw that circle by center. '81. Zoom in, and then you have another diameter protruding out 40.76 downwards. Again take circle by center, 40.76, and then come to your home view. We'll extrude it. So the outer one, right click, is extruded for 3 mm, and the bottom one is extruded in the opposite direction. I think it took some value by default. Let's do that again. Extrude, click, right click, bottom. So that is about 2 mm. Done. Now we have a protrusion here. So this is, if you can remember, this is where your propeller goes in. So this is 16. The whole thing is 16. Again, go to your top view and create this on this plane. So come to the edge, and this will be 16. Right click, home view, extrude, right click. I think the whole height is about 8 mm. Done. And then you have another plate here. So the dia of that plate, you can see from here, is 52. No, sorry, it's not 52. 52 is the line that these holes are in. This is 16 plus 11 plus 11, so 16 plus 22. We'll go to the top view. Click on this plane, lock it, 16 plus 22. Remove excess. Now extrude this plane, right click, 3 mm. Done. I think we have our basic design. Now we'll have to punch those holes. Go to your top view. First take circle by center, and on this plane, first lock the plane, and on that plane, from the center, you draw 52.2. Okay, and upon those you have 8 dia circle by center, and on the same plane intersection draw 8 dia and another 8 dia. Now you can select this and remove this line. Now draw another circle by center. That will be drawn on this plane. what you do, you just click escape and come out of the plane. Okay, those circles are correct. Top view, circle by center on this plane. Dia is again 8. Right click, go to home view. I think that is okay wherever you draw. You're actually supposed to draw it outside of it, but since it is a hole, it can pass through all of it. Only important thing is you make sure that this is on this plane itself. I mean, even if it is not on that plane, you can still protrude it out, but we'll use the option through all. So therefore, take this symmetric through all, negative, and right click, direction, like this. Done. Front view, top view. It is a bit tilted, it's okay. While assembling, just make sure however the direction is mentioned, and then you can see here it has a round. So it has round, round. Select this 1 mm, enter 1 mm, here 1 mm, here 1 mm. I think bottom plate you don't have round, so we'll leave it at that. I think there is camphor here because you can see it is going down, so we'll give another round here for 1 mm. So this is how it is supposed to look in the front view, and I think it is okay. So save this. Mount plate. Next we'll try to draw, we'll make the face plate, new metric part. Okay, top view. I think the biggest diameter is 38 mm. So sketching, circle by center, circle by center, 38, fit, and then you have got an 8 hole dia. So 8, enter. Now what we'll do, come to your home, extrude, take face now, this face, symmetric direction, right click for 3 mm. Done. Now go to your round, 1 mm, 1 mm, 1 mm above, 1 mm below. Right click. So the way you intend to say it, you obtained it. Done. Save as. Faceplate. So we'll do our next part, that is the lock bolt, new metric part. Close all of this. No necessity, it's not necessary to close, but it might lag So what we'll do, we'll draw the first one. So that is we'll draw from the base up. So the minimum is 8. Go to top view. Mm. Done. Fit. Come to home, and then use your extrude option. Extrude. Right click. This is about. Take it in one direction. This is about 35 mm. Enter. Fit. Now go to sketching, top view. On this draw your next one, that is 16 mm. So 16 mm, and go to home. Now extrude this for 8 mm. Okay, I think the mistake was we didn't select the chain. Solid. This is not a face, it's a chain, I think, but we do need the face. Let us see. Control dot plus dot. Right click. Upward. Okay, we will draw the hole again later on. So this is 8. Now this is something new that you guys will study. Is all of 8 with V bottom. Go to solids, hole, and in here you take simple and double click on this, and then convert the standard to mm and finite extent. Hole depth from the dimension sheet is 5.5. Couldn't enter it correctly, so hold at 5.5. Switch on this V bottom, and diameter of the hole is 8. Okay, and okay, now come to the center, click, your hole is done. So this has got camphor equal setbacks 1 mm and 45 by default it will take. Enter. Done. So once all of your parts is done, we'll go to assembly, metric assembly, and in the tree you'll select where you did your propeller parts. Okay, this is too extra that I admit, don't worry about it. And we know first thing is mount plate, drag it onto your screen, and then done. Okay, next we'll add a face plate. First alignment is axial, so this axis on this axis. Okay, now then this plane should touch this plane. Done. Now that is done. We'll take our propeller. This was a 3-winged propeller I designed. We'll take a 2-wing. Okay, take our propeller. First again axial, this axis on this axis, and this surface should touch this surface. And finally we have our lock bolt. Again same. Axial, this axis upon this axis, and this plane on this plane. Press escape. Your materials is done. Just check if you're able to drag this along. Yes, so you're able to rotate it. Okay, one thing I've missed before is to assign the materials, which I've done for this assembly already, but I'll still show you. You'll have to go to inspect, and here properties manager, and in that properties manager you'll have a material. So what material belongs to what? So lock bolt is actually steel. It is given in your dimension sheet, steel, and propeller is made of wood, any type of wood, you don't need any specification, and faceplate is made up of MS, which is nothing but your mild steel. I didn't find mild steel option here, so just use steel. Mild steel, and then you have your mount plate as, again it's also steel. Update all. Okay, so you can see the material has been added now. So this will help you in your structural analysis. So when you take this and go use any of the other softwares, probably ANSYS or anything, you can directly implement it and then apply your load. So it will take what is a structure, what force it can withhold, and all those parameters, which you'll probably learn in your 7th semester. Okay, so now this is done. One more thing I didn't mention last class is that there's something called ISO constraint. Meaning, constraint by definition means that when constraining is how many degrees of freedom does a body have. So if this fan has got, so it has got only 1 degree of freedom, that is it can rotate in, that is your rotational motion, correct? So it can rotate like this. It can't go up, it can't come down, or it can't go sideways. So the other two freedoms are constrained. So the ISO constraint is to see your assembly's ISO constraint is you just make sure that all of the cubes here are completely cube, and upon them there is no any exclamation, question mark, or star. Okay, once you know this, then your assembly is ISO constraint. For the mount plate or the base element, what you take, there is a star element, that is okay, but rest all should be free and be completely a cube. Okay, so this completes your propeller hub assembly.